Hello! What you are watching right now is not just someone cooking a delicious meal, but also the basic heat transfer effects of conduction. In this example, heat travels from the stove through the conductive material of the pan to cook the food. Notice that the chef in the video is using a wooden spoon rather than a metal utensil. This is because wood conducts less heat than metal, preventing the chef from burning his hand. Besides cooking our food, conduction has many other real-world applications, including the ability to curl our hair, when used right. To demonstrate the effects of conduction, we're using invisible ink, just like Nicolas Cage in National Treasure.
Lemons.
You can't do that.
But it has to be done.
By comparing how dark the secret messages show up after the decoding process, we will quantify the amount of heat transferred with varying source temperatures. The materials necessary for the secret messages are any organic acids such as apple juice, lime juice, or vinegar. We're using lemon juice since we found that it worked best. Equally sized strips of paper, a writing utensil that could be a Q-tip or toothpick. We're using a mechanical pencil with the lead taken out. And a hair straightener. Start off by dipping your writing utensil into the lemon juice and writing on the paper. Wait for it to dry completely before the next step of the process. Be sure that the juice is not soaking through the paper or you'll need to leave it in the straightener for a longer time. For our particular experiment, we will use equally sized dots for consistency. The end result will look like this. To keep your messages a secret, remember that the less lemon juice that soaks through, the less visible it will be before the decoding process. Place the paper into the straightener. For our experiment, we tested 6 different strips of paper for 20 seconds with increasing temperatures. Strip 1 was the lowest temperature setting of 350 degrees Fahrenheit, while strip 6 was the highest at 450 degrees Fahrenheit. After taking the paper out of the straightener, you can read your messages. As you can see, higher temperatures result in darker messages. We actually measured how dark the messages were using a program that quantifies color intensity. The following graph shows the nonlinear relationship between the color intensities versus the temperature settings of our hair straightener. The invisible ink only works because of conduction. Conduction is the process of heat transfer due to direct contact. When the message is heated with our heat source, the hair straightener, the organic compounds react and turn into a darker color, which we can now see. The 2 heating plates are directly touching the paper and the lemon juice. When the temperature of the heat source increases, the amount of heat transfer also increases, driving the reaction further to completion by reacting more organic compounds in the lemon juice. Therefore, the messages appear darker at higher temperatures. Conduction has many real-world applications beyond our invisible ink experiment that rely on chemical engineers in order to occur. For example, chemical engineering is important for controlling the tempering process involved in the production of chocolate. Tempering is the crystallization process that involves heating and cooling chocolate in order to create a bar that is smooth and glossy and more resistant to melting than improperly tempered chocolate. Since chocolate is sensitive to heat and can scorch easily, chemical engineers are needed to understand how the conductivity of chocolate changes as it solidifies, so that the amount of heat transfer can be adjusted accordingly during the crystallization process. In addition to our previous example of cooking food, the amount of heat transferred from the stove to the food depends on the conductivity of the pan, which in turn depends on the materials the pan is made of. Chemical engineers are responsible for choosing the materials best suited for pans while keeping other design parameters in mind, such as safety and cost. Now don't go burning the food in the pan! Burn those organic compounds in that invisible ink. Thanks for watching! Bye! Go Blue!